When interviewers ask, "What's the difference between overfitting and underfitting?" they're testing whether you understand model generalization, one of the most common challenges in machine learning. Let's keep it simple. Underfitting happens when your model is too simple to capture real-world patterns in the data. It performs poorly on both training and test sets. You'll notice high training error and high test error. The solution is to make your model more flexible, add features, increase complexity, or reduce regularization. Overfitting, on the other hand, happens when your model becomes too complex. It learns the noise along with the signal. It performs extremely well on training data but fails on new, unseen data. You'll notice low training error but high test error. To fix it, you can simplify the model, use more training data, apply regularization, or perform cross-validation. In an interview, always explain both, because the real skill is knowing how to find the balance between the two. Now, how do you actually detect overfitting or underfitting in real projects? That's where practical diagnostic tools come in. First, learning curves. Plot your training and validation errors against the training size. If both curves are high and close together, your model is underfitting. If there's a large gap, low training error but high validation error, you're overfitting. A good fit shows both curves converging to a low error. Second, performance gap analysis. Compare metrics between training and test sets. For example, 95% accuracy on training but only 70% on test data. That's a clear signal of overfitting. A consistently low score on both sides usually means underfitting. Third, cross-validation scores. If your validation scores vary a lot across folds, the model is unstable and likely overfitting. Stable scores indicate better generalization. Here's an interview tip: don't stop at definitions. Share an example from your own experience, like how you spotted overfitting using a learning curve and fixed it with dropout or regularization. That's what shows real maturity as a data scientist, not just knowing the theory, but diagnosing and improving model performance.